Namaskar. I welcome you all in this class of mathematics. So, in the previous class, we discussed about quantity and intervals. Now, today we are going to discuss functions, but one thing the time was over in last class. So, we could not discuss the finite and infinite interval. So, there is a little difference, finite and infinite interval. As I told you, the length of interval say I is equal to a b, a is less than b, element of R. So, length of any interval will be equal to b minus a. If this is finite, this is a real line ranging from minus infinity to plus infinity. So, if this is finite, say this is the range, then this interval a and b, we call it a finite interval, but interval may be infinite. Suppose I is equal to x element of R such that a is greater than or equal to x, then this is an infinite interval. So, x is such that it is greater than or equal to a. So, starting from this, the value of x will go to the infinity. So, I will be equal to a, because a is inclusive equal to here. So, a is included comma infinity. Similarly, the other interval x is an element of R such that x is less than a. So, this will be equal to minus infinity to a, open, both sides open, because a is not included here. So, this will also be an infinite interval. But one thing you should remember, that an interval is a set having infinite many elements, but any infinite set is not an interval. Say set of natural numbers 1, 2, 3, 4 to infinity. This is not an interval. Why? Because this is not continuous. If you go on this line, here may be 1, here may be 2, here may be 3, but there will be infinite many points in between which is not the element of this set. So, this is not an interval. Similarly, Z or W, set of whole numbers or set of integers, these are also not intervals. Now, let us define functions. Very important functions will come along while going through mathematics. You will learn many things about functions, many operations on functions. So, function is a very important for you. How do we define function? Suppose two sets are there, x and y. So, there is a relationship between x and y, some association that we call a function. So, suppose these are two sets, this is x, this is y, and these are related by a function f. So, its elements are x1, x2, x3, x4, and here the elements are y1, y2, y3 and y4. So, for each element of x, there is unique element of y association. Is it a function? Yes, it is a function. There are two rules to be followed in a function. For being a function, two rules. Number one, that the first set domain, we call it, each element of x, each element is associated to some element in y. This is the first rule. What about second rule? Two rules are there. Second rule, that each association should be unique. Each association of x should be unique in y. What does it mean? It means that here you can see each element has an association, x1, is associated to y1, x2 is associated to y2, x3 is also associated to y2, x4 is associated to y3. So, it says only about this is called domain, X is domain and this is codomain. So, we define function, any function x to y, where x is domain and y is we call codomain. So, here two things should be there, two rules are there, that all the elements of domain should have association to some element in the codomain. Okay. So, each element, this is the first rule. The second rule is that it should have unique association. So, x1 is associated with y1, x2 is associated with y2. It cannot be associated with y3 also. It should have unique, only one association. Y can have x3 is also associated with y2, but x3 has only one association and that is unique. Y4 has no association. So, you can understand to remember that suppose X is a set of all the babies and Y is the set of mothers. So, each baby will have a mother. So, each baby must be associated with some element of Y. So, one mother will be there and a baby cannot have two mothers. So, it should be unique. So, you can see x1, x2, x3, x4 everyone has a mother and it is unique, it cannot have two mothers. Okay. But here you can see that two elements are associated with y2. Yes, it is possible because a mother can have two babies. Now, y4 is not associated with any of the element in X. It is also possible because y4 is a mother, but she is not having a daughter, she is having only son. So, here all babies are there, girl child. So, no element is associated with y4. So, this is a function. To remember this example is this is a good example. You can remember this way the function is defined. Suppose now I will give you some example here. Suppose this is x, this is y, here x1, x2, x3, x4 elements are there, maybe more elements, many elements, can infinite set also. Here y1, y2, y3, 3 elements are there. So, a function is defined between x to y. Is it a function? It should follow these two rules. Here you can see x 4 has no association. So, this is not a function, because every element, each element of domain should have association and an unique element in y. So, this does not qualify for a function. Again, let us take another example. Two sets x and y, we define a function from x to y x 1, x 2, x 3, y 1, y 2, y 3, y 4. Suppose this is the association. Is it a function? Again, if you see those two rules, each element of x has an association with some element in y, yes, it satisfies. But what about uniqueness? It should have a unique association. So, x 1 is associated with y 1 also, x 1 is associated with y 2 also. So, this does not qualify for function. Why? Because it violates the rule 2. Uniqueness is not there. Now, we will see some example of function. Say a function we defined f n such that from set of natural numbers to set of natural numbers. So, we define f n is equal to 5 n. This is the equation. So, it means that f 1 is equal to 5, f 2 is equal to 10, f 3 is equal to 15. So, you can see this is an infinite set of natural numbers. So, 1, 2, 3, 4, 5, 6. Here also set of natural numbers 1, 2, 3, 4, 5, 10, 15 and so on. So, if we define f n from n to n, you see 1 is associated to 5, because f 1 is equal to 5, f 2 is equal to 10, f3 is equal to 15 and so on. So, for all elements of n, any element of natural number, you will find some element uh, as per definition 5n, this will also be in the set of natural numbers. So, what will be domain? Domain is all natural numbers because it is defined. What about codomain? Codomain is also set of natural numbers, but there are many elements, say here 1, 2, 3, 4, for which the function is not defined. So, what happens to them? So, then we define range of function. What is range of function? It is included only those elements of codomain for which the function is defined. So, this will be here 5, 10, 15, 20 and so on. This is also an infinite set. So, this is called the range of the function for which the function is defined. Let us take another example. Suppose f x is equal to 3 to power x. So, this is a function r to r. So, for all x, 3 to the power x is defined but you can see that 3 to the power x cannot be a negative number. So, it is only positive numbers will be there in the range. So, f1 will be equal to 3, f2 will be 9, f3 will be 27 and so on. So, r to r, this function is defined, but its domain is r, but what about its range? Its range is 0 to infinity because it cannot take negative values. Now, let us take another example. You can see similarly you can find out the domain and range of a function. Suppose f x is equal to 1 upon x minus 3, x element of real number. So, this function will not be defined at x is equal to 3. So, its domain will be r minus 3 because it is not defined for 3. Okay. Similarly, f x is equal to 1 upon x plus 5. So, for x is equal to minus 5, it is not defined. So, its domain will be equal to r minus 5. So, this minus 5 will not be there, otherwise it is defined for all other elements. So, similarly you can find out the domain and codomain and range of a function and the value of a function. So, next class we will discuss about type and graphical representation of functions. Thank you.